All right, so I'm going to be talking about Lunar Trailblazer, which is actually a ride along on one of the CLIPS missions. We were originally selected in June of 2019, and we weren't planned to fly with CLIPS. We were kind of planned to fly with whatever we could fly with, and we originally manifested with, oh my God, I'm having with IMAP. It would have launched in 2025, but the CLIPS office was able to accommodate us launching earlier with the Intuitive Machines IM2 mission. So we're really excited about that. And we think that in addition to the orbital science that we're going to be really blazing trails with on Lunar Trailblazer, this is a good model for how we can get orbital assets into space through the CLIPS program. So we hope that NASA takes advantage of that more in the future. So as I mentioned, we're going to be launching later this year in probably third or fourth quarter of 2023. The mission is run out of Caltech by Bethany Ellman, and I'm the deputy PI. And what we've designed the mission to do is to look into this problem that you heard a lot about this morning of lunar water, understanding the character of the lunar water, migration of lunar water across the surface, understanding what form it's in, and really trying to follow up with data that's tuned to actually analyze the properties of that water in a way that M-cubed wasn't designed to do, because we didn't expect to see water when we flew M-cubed. So the way that we're doing that is with two instruments, the HV-M-cubed, which is basically a descendant of the M-cubed mission, but designed now to cover that full wavelength range of the 3-micron band. So we go from 0.6 to 3.6 microns, and we maintain that full spectral resolution that you saw in Janice's talk with the 10 nanometer spectral resolution, so that we can distinguish features, OH features from water features, and do a lot better with the modeling and trying to understand what water may be indigenous to the moon and what water looks more like something that's more formed with interactions of the solar wind or other properties on the lunar surface. Now, in addition to this, one of the biggest bugaboos, I'll use like a Carly word there, has been that we need to understand the temperature very clearly of the surface at the same time that we're measuring the spectral properties in the near infrared. So to do that, we've got the LTM instrument, which is being provided by Oxford University, to understand that it is embedded within the field of view of the M-cubed images and characterizes the thermal properties at a finer scale so that we can understand even sub-pixel what the thermal properties of the surface are. So I said I would keep us on time, and I probably won't, because that was only my first slide. All right. So our goals are, like I said, to determine the form, abundance, and distribution of water on the surface. We want to understand any possible temporal variations. We also want to look into the permanently shadowed regions. So we have two modes, and I'll show a little bit later a little bit more about our PSR mode, but we will integrate longer, and we'll be able to actually get pretty high spatial resolution within the permanently shadowed regions to understand whether we're looking at ice or other mixtures of ice in the regolith. And then finally, we want to look at all of this as a function of composition, albedo, geology, all of that, so that we can really start to disentangle a lot of the questions that we've got about water on the moon. So because I usually end up talking about science for like 10 minutes and then never talk about the instruments, we flip this one on its top a little bit. So the mission status right now is that the HV-M-cubed instrument is not only built, but it's been integrated onto the spacecraft. Here are some cool hardware pictures of that being done. It was integrated at the end of last year. All the requirements are being met with flying colors. Just this week, they've been integrating LTM and aligning it to the HV-M-cubed instrument. That's a picture of Tris, I believe, in the thermal IR, if anyone wants to, there we go. I see him in the visible, he's up there, but in the thermal, there you go. So we're very excited about that. Requirements are also being met on that. Here are some images of the spacecraft. This was after the TVAC. So the spacecraft is well on its way. Basically, we still have to do work with installing the solar panels. LTM actually probably is installed at this point, because this was from earlier this week. Vibe, magnetic interference, all those things. And we're going to be ready at the end of the summer, which is just crazy. This entire thing. So I'm also on Lunar Vertex, and the speed that these missions come together is like completely astounding compared to what most space missions do. So this is an incredibly exciting time to be in the lunar community, and everyone should be very, very happy about that. We're really lucky. So now, in addition to being fast, a lot of these missions are very budget constrained. And one of the things that Bethany has written into this, which is really fantastic to me as a former community college student, is working with community college students in Pasadena, as well as the students at Caltech, to bring more opportunities to the community, involve more people in space, but also to help develop some of these tools like science scheduling, graphics, mission website. We're bringing in students that didn't really have access to this in the past, and bringing them along on this ride to make sure that not only can we execute the mission in the constrained cost, but also that we broaden, the involvement on the return to the moon to more of the world. So that's been a really, really nice aspect. And that's the wrong thing to click. So like I said, we'll be riding along. Exactly when we launch will determine how long we spend in cruise to get there. So that's a picture of how Lunar Trailblazer will be on the little Espogrande ring at the bottom of all of the stack. And once we get there, what we're going to do is we're going to be collecting images in a targeted mode. So it's a small satellite. We don't have tons and tons of data. We have to very carefully choose our targets to follow up on the questions that we have. So we have requirements to view specific geologic targets, requirements to view certain targets that we understand their composition very well at multiple times of the lunar day, to understand the mobility questions. And then, of course, we've got the PSR targets that we'll be looking at. So as I said, we're collecting these kind of nested data. Here's a visualization of a hyperspectral image cube, and then how we have this kind of like inset thermal cube that will be within the data, and then some examples of the, especially in the 3 micron region, what types of data we can distinguish with the spatial and spectral resolution that we'll have. And then, of course, the 11 thermal channels that span the Chris-Johnston feature region, where we can really characterize that absorption in great detail. All right, so I am almost out of time. So I mentioned the PSR measurements. So we've done some simulations based on the performance of the instrument, and using just terrain scattered light, we're able to really peer into these shadows and understand what we're seeing spectrally. So this is an example of looking at difference measurements between molecular water and ice, and the signal that we're getting, basically, that by doing these differential measurements, we can distinguish 1 per 100,000 difference between these two species in terrain scattered light. Click. And there's some lines of how things scatter. So we'll be putting all this together into products, looking at the thermal properties, these kind of like, it probably won't be mineral maps, but it will be like parameter maps to understand where we're looking at different species of water and water hydroxyl ice, different minerals, all of that. Those will be delivered to the community. And finally, before I'm fully out of time, this is just a visualization of the size of the pixels that we'll be getting the actual usable spectra for within some of these permanently shadowed regions. So a lot of the M-cube data that we've had to that we've looked at to identify the ice, that Shuai Li especially has looked at to understand that, have had to be binned up spatially quite a bit to get the signal that we need, and we won't have to do that to the same extent. So anyway, Lunar Trailblazer is going to be really exciting. We're accomplishing really high impact science in a very small, tightly constrained budget and size and everything else. We're going to have our data, we're targeting future potential landing sites, former landing sites, to really try to also help to feed into the exploration side of things. And we're super excited to be a part of this. Thank you, everybody.